can start now.
Okay, thanks, Ahmed. Okay, good morning. Hello, everyone, and welcome to the Refining Module online sessions. Let me introduce myself first. My name is Pilar de Salvador. I'm process engineer, and I'm looking forward to starting with you this refining module. I have more than 20 years of experience in oil and petrochemical. In this module, we will talk about all the process units of the refinery. In today's session, we will begin with a brief review of general concepts about crude oil and hydrocarbons. So this first session today, we will cover 3 presentations. What is crude oil overview, and hydrocarbons. I am sure that many of the terms and definitions that we will see today are familiar to most of you, but this is like a refreshment of these basic concepts. The content of the presentation is as follows. We will see the crude definition, how it's formed, explored, and produced. After, we will talk about crude oil transportation. Then we will cover crude oil reserves, storage, and uses. And last, we will talk a little bit about the Carvara refinery scheme. Okay, let's start with the definition. Crude oil, commonly known as petroleum, is a liquid found within the earth comprised of hydrocarbons, other organic compounds, and small amounts of metal. Also, the word petroleum comes from the Latin roots the petra, meaning rock, and oleum, meaning oil, okay? The crude oil, these hydrocarbons, are mainly hydrogen, about 13% weight, and carbon, about 80%. Other elements also you will find in the crude oil that will make the life more difficult to the refinery. These other elements are nitrogen, sulfur, oxygen, and metals, such as iron, nickel, and copper. Can also be mixed in the hydrocarbons in small amounts. As you know, the organic compounds are these related with carbon and hydrogen, and the organic compounds are where carbon is present, covalent linked to other atoms. Commonly also, the crude oil sometimes is called the black gold. The crude oil is compared to gold due to its valuable properties and the price of the product that we can get from the crude oil. Black because, well, but crude oil in fact can vary in color from black to yellow depending on the hydrocarbon composition. Which volume unit do we use for the crude oil? The standard volume unit for crude oil measurement is the barrel, the 42-gallon barrel. This 42-gallon barrel is about 159 liters or 35 imperial gallons. This dates back to the 1860s when Pennsylvania producer actually stored and transported petroleum in wooden barrels. Okay, they use this wooden barrel to transport the crude oil. In countries that use the metric system, oil volumes may be measured in metric tons. Because the density of the crude oils are not the same, a good approximation, we can make the conversion to metric tons using more or less this conversion, that 1 metric tons equals to 2,204 pounds. The abbreviation BBL for barrel, it is typically thought to originate with the Standard Oil. That is the first oil giant producer in the US because they use blue barrels to store and transport oil. That's why the BBL abbreviation for barrel for the crude oil, uh, 42 gallons. Let's talk about some crude oil facts. Crude oil is a naturally occurring fossil fuel, meaning that it comes from the remaining of dead organisms. Okay, as we talked before, crude oil is made up of mixture of hydrocarbons, hydrogen and carbon atoms. It exists in liquid form, in underground reservoirs, in the tiny spaces with the sedimentary rocks, or it can be also found near the surface in oily sands. It is often found alongside with natural gas and saline water. It is non-renewable because it takes millions of years to form. Here we can see also other non-renewable energy like coal, natural gas, and the nuclear energy. Of course, oil is cleaner than coal, but it also has some disadvantages, like the air pollution created in the refining, also in the transportation, and also the burning gasoline and other petroleum products releases some CO2 that, as you know, this still contribute to the greenhouse effect and increases the global warming. And also we have had in many occasions some oil spills that can cause great environmental damage. Okay, so we have to be very aware of the environmental impact of the crude oil transportation and refining. How the crude oil is formed. The crude oil is formed from the remains of dead organisms, the diatoms, such as algae and zooplankton, that existed millions of years ago in a marine environment. These organisms were the dominant form of life on Earth at the time. Okay? As they live, these organisms absorb energy from the sun and store it as carbon molecules within their bodies. Once they die, their remains sank to the bottom of the ocean of riverbeds and were buried in layers of sand, mud, and rock. Over millions of years, the remains were buried deeper and deeper under more sediment and organic material. The enormous pressure, high temperature, and lack of oxygen transformed the organic matter into a waxy substance called kerogen. So you see here where this organism, and they start to be buried by the sand and the silt. The three factors that are the precursors to the crude oil to be formed are pressure, high temperatures, and lack of oxygen. With even more heat, pressure, and time, the kerogen, the previous component that we saw in the previous slide, undergoes a process called catagenesis, which transforms the kerogen into hydrocarbons. The catagenesis is a term used in the petroleum geology to describe the cracking process. It is a cracking process, so you crack the molecules and then results in the conversion of organic kerogens into hydrocarbon. Different combination of pressure, heat, and the original combination of the organic material will determine the type of hydrocarbon formed. In this case, the hydrocarbons from crude oil. Okay, if you go to more pressure, more heat, then you will get more natural gas. After the oil is formed, it moves through tiny pores in the surrounding rock from an area of high pressure to low pressure. Yes. That is often upwards in this sense, from the bottom to the top. Some oil may make it all the way to the surface when it pulls without restriction, no? But in other cases, the oil will get trapped under impermeable layers of rock or clay where it will form the underground reservoir. So we can have a free path for the oil. All the oil can get trapped on underground reservoirs. So let's talk about a little bit about what is the exploration and production. Of course, this is a complete subject, very specific, that it requires a lot of study and a lot of understanding. We will give here some brief concepts of this exploration and production. The definition is that exploration and production is the early stage of energy production, which includes searching and extracting oil and gas. In the oil and gas sector, this stage is referred as upstream. Then we have the middle stream and the downstream sectors. The land surveys are performed to locate the specific mineral underground in order to estimate the amount of oil and gas reserved before drilling. There are several processes involved, but one of the processes that can be used involve the seismology. This process uses substantial vibration as a result of machinery of explosive to create the waves, the seismic waves. So they know through this seismic wave uh, they can find the reservoir location. Okay, this as you can see here, this is well in the sea, but they can create like a seismic vibration, and then they put here like hydrophones in this case, that is a microphone to be used on the water for recording or listening, no? The underwater sound. So they can, through these sounds, they can know more about where is the reservoir located. And this artificial energy, the seismic energy, is often generated by uh, vibratory mechanisms, like that will generate like seismic waves. Okay, so these waves reflect and refract the rock formation and travel back to these acoustic receivers. Okay, in this case, hydrophones, because they are on the water, but also in the land, they call it geophones. So the travel times that is measured in milliseconds of the travel time of this return seismic energy, they will give you more information about the type and the location of the reservoir. So once it has been determined that there appear to be the reserve beneath the ground, the test drilling process can begin. So let's talk about the well construction. After you have identified the potentially viable fields, a well is drilled to test the findings and determine whether there are enough reserves to be commercially viable for sale. The process involves making a hole by drilling or grinding through the rock beneath the surface. Okay, so a steel pipe is inserted into the hole so that the drill can be inserted into the pipe, allowing for exploration at a deeper level. So I can take some samples, and these samples are studied by geologists, engineers, and paleontologists to determine if the natural gas of petroleum is it has a proper quality. If all this process shows that there are both the quantity and quality needed to be produced and sold commercially, the production of oil wells begins. How they construct the well? Well, okay, engineers will typically estimate how many wells will be needed and the best method of extraction. Okay, the estimated cost of the number of wells is determined. Next, the construction of the platform begins. This can be land or offshore. The necessary environmental, of course, protection are also implemented at this stage. There, of course, through all these years, there have been significant advances in drilling technologies. Companies can drill also horizontally, tapping into vertical wells to search for natural gas pockets, which can produce more natural gas than a typical vertical well. Okay. Although they are very useful, this horizontal drilling is as 3 times more expensive than vertical drilling. However, this extra cost is generally made up for with the increased well production. Okay, uh, so also depending on the crude oil price, the companies will go to this more expensive process. That is the horizontal drilling. How do we extract the crude oil? Well, in some places, petroleum bubbles to the surface of the earth, okay, without any other mechanism. In part of Saudi Arabia and also in Iraq, for instance, porous rock allows oil to seep to the surface in small ponds. However, in most of the cases, most oil is trapped in underground oil reservoir. Then we will see how to extract the oil from this underground oil reservoir. The total amount of petroleum in a reservoir is called oil in place. Okay. Many petroleum liquids that make up a reservoir in place are unable to be extracted. Okay, because maybe there are it's very difficult, dangerous, or expensive to drill it. So this oil in place is a term in petroleum geology that refers to the total oil content of an oil reservoir. As this quantity, of course, cannot be measured directly, it has to be estimated, okay, from other parameters measured prior to drilling or after the production has begun, okay. So the oil in place will be the total oil content of a reservoir, okay. We will see later that is different from the concept of reserves of crude oil. This is the total amount. So the part of a reservoir oil in place that can be extracted and refined is the oil reserve. Okay, so it's different for the oil in place. This is the decision to invest in complex drilling operation is often made based on a site's proven oil reserve. So we can see that the oil in place must not be confused with the oil reserve. The oil reserve are the technically and economically recoverable portion of oil volume in the reservoir. Okay, we will see in the next slides the recovery techniques that will be used to recover this oil in the underground reservoir. On land, oil can be drilled with an apparatus called an oil rig or drilling rig. Offshore, oil is drilled from an oil platform. So first, a crude oil well is created by drilling a hole into the earth with an oil rig. A steel pipe is placed inside, as we saw before, the oil well for structural strength. Then holes are made at the bottom of the well so oil passes through the base. Collection valves are fitted at the top, and this valve maintain pressure when crude oil is pumped. Okay. So typically the recovery factor for the oil fields around the world range between 10 and 60%. Okay. Some can reach up to 80%. So this variance of the oil that we can recover is mainly due to the diversity of fluid and reservoir characteristics for different deposits worldwide. Okay, so let's talk about the process for the recovery of the crude oil. We have mainly three: the primary, the secondary, and the tertiary recovery. So the primary recovery is the first stage of petroleum and gas production. The crude oil extraction from a new well relies on the natural rise of the oil due to the pressure differences between the oil field and the bottom hole of the well. Also, you can use the mechanical lift systems like a rod pump that is also called a primary recovery. In this stage, with the primary recovery, you can get uh, between 5 to 15% of the oil in the reservoir. Okay, so this primary recovery is natural flow and also artificial lift that are called the pumps. Okay, the secondary recovery is used after we have recovered all the crude that we can with the primary recovery. So a secondary recovery will be used. How do we increase the natural flow of the oil? So we can increase the natural flow, increasing the reservoir in the pressure reservoir. How do we increase the pressure? Injected water or natural gas into the well. Okay, so this is what that we call the secondary recovery, that is to increase pressure. Okay, so we can increase the pressure with water or with natural gas. How much crude we can recover in this secondary recovery? Up to between 35 to 45% of the oil in the reservoir. So this is a natural, the secondary recovery is based on increasing the reservoir pressure. What is a tertiary recovery? Tertiary recovery is applied when the crude oil extraction from secondary recovery becomes impossible. In this method, in this process, water, gas, and chemical are injected into the reservoir to improve the natural flow of crude oil. Finally, crude oil is extracted. This stage allows an extra 5 to 15% of the oil in the reservoir to be extracted. Of course, this tertiary recovery is more expensive than the other two processes. So when crude oil prices are high, this process can be used to increase oil extraction. The primary purpose of this tertiary oil recovery is to reduce the oil viscosity. Okay, so the we can go to this process of the increasing the viscosity, decreasing the viscosity with these processes. The fluid that we get from the well is a combination of crude oil and natural gas. It is often mixed with water, non-hydrocarbon gases, and other impurities. The natural gas that we get when we get the crude oil is called the associated natural gas, okay? Because it comes with the oil. The first step in processing this fluid is to route to centralized surface handling facilities, where vessels are used to separate the oil, water, and gas into individual streams. The water that we get usually is pumped back to the reservoir. If we cannot pump back to the reservoir, we dispose in an environmental friendly manner. The oil that we get is measured and stored in tanks to a wet pipeline or tank is transported to the point of sale. So in this case, the oil that we get from the well is stored and then sent to the refineries for further processing. And the gas is treated or conditioned to remove water, white vapor, and other impurities, and processed to recover gas liquid before being metered and sold. Okay, so there are quite important both the crude oil and the natural gas from the wells. How do we transport crude oil? The most commonly used is to transport the crude oil by pipeline. These pipelines require significantly less energy to operate than truck on rail and have a lower carbon footprint. You use a pump and then you pump from one place to another through these big pipelines without with a less energy consumption than other methods. The carbon footprint, it is the total greenhouse emission caused from an individual event. No? So it is says that this is the lowest carbon footprint process involved in transporting crude oil. Also, we can transport the crude oil, by rail, by trains, and this also has become a growing phenomenon as new oil reserves are identified across the globe. Also, we can transport the crude oil by truck, but this is limited by the storage capacity. But also they have a great flexibility in reaching all the destinations. But of course, the cheapest way to transport the crude oil is by ship, where you can transport very big amounts of crude oil. If we compare a barge that is like a small tanker, that is 30,000 barrel capacity, you can carry the equivalent of 45 rail tank at about one third the cost. Okay, so it is the most economical way to transport. Nowadays, you can have tankers that can carry up to 2 million barrels of crude oil. So they can if you multiply by the crude oil prices, they are very expensive material inside each tank when you transport for these very big quantities of crude oil. So we have seen that we can transport the crude oil in four ways. By pipeline, there is more use when you transport crude oil within a country or with neighbors countries. You can also transport by train. You can also transport by truck or by ship. Let's talk a little bit about the crude oil reserves. For this, we have to talk about the OPEC. The OPEC is the Organization of the Petroleum Exporting Countries. It was created at the Baghdad Conference on September 1960 by Iran, Iraq, Kuwait, Saudi Arabia, and Venezuela. The mission of the OPEC is to coordinate and unify the petroleum policies of its member countries and ensure the stabilization of oil markets in order to secure these three items: an efficient, economic, and regular supply of petroleum to consumers, a steady income to producers, and a fair return on capital for those investing in the petroleum industry. The crude oil reserves. All continents all have oil and natural gas reserves, although they are very unevenly distributed. In the Middle East, there are huge oil fields, with half of the world reserve. In the Gulf of Mexico, the North Sea, and in the Arctic, both Alaska and Russia, there are also large reserves. There is a belief that there are large reserves on the continental shelves, that are the seabed areas near the coast and located between depths below 200 meters. For various reasons, ecological mostly, these reserves are not even located. We can see that the 77% of the reserves are found in the 11 countries belong to OPEC: Saudi Arabia, Algeria, United Arab Emirates, Indonesia, Iraq, Iran, Kuwait, Libya, Nigeria, Qatar, and Venezuela. In the following graph, we will see the oil reserve in 2018. So we can see that these are the OPEC members. These are not OPEC members. We can see that the proven crude oil reserve in billions of barrels. In the first place, we have Venezuela, then Saudi Arabia, Iran, Iraq, Kuwait, and in the last, the Equatorial Guinea. Okay, so the oil reserve. Remember that is the amount of crude oil that can be technically recovered at a cost that is financially feasible at the present price of oil, okay? That is different from the oil in place that we saw before. That is the total amount foreseen to be in the crude oil well, in the crude oil that we are evaluating, the crude oil place. So the reserves will change with the price, okay? These are the crude oil reserve and the production nowadays. The United States is the top oil producing country in the world, okay? They produce like 80 million barrels per day. This is also because they are also using the fracking process in the shale formation, mainly in Texas and North Dakota. So nowadays, despite the increasing proliferation of an alternative energy source, the oil production continues to play an important role in the global economy. Okay, so now we will see the how do we store the crude oil. The crude oil untreated and unrefined is stored in tanks for shipment to other location of processing into finished product. So there are four basic types of tanks used to store petroleum products. We have the floating roof tank used for crude oil, gasoline, and naphtha. Also, we have the fixed roof tank that we use for diesel, kerosene, catalytic cracker feedstock, and residual fuel oil. The bullet tank used mainly for normal butane, propane, or propylene, and the spheric tank used for isobutene and normal butane. This is a specific topic, the storage tanks, but I can tell you that these tanks for a particular fluid are chosen mainly according to the flash point of the substance. Okay, being the flash point the lowest temperature at which a liquid will form a vapor in the air that can expose you to ignite or to open flame. So the flash point is a general indication of the flammability or combustibility of a liquid. Okay, so this defines the kind of storage for a specific product or for the crude oil. How do we use the crude oil? To be used to us, the crude oil must be fractionated into its various hydrocarbons, and this is done at the refinery. Oil can be used in many different products, and this is because of its composition of many different hydrocarbons of different sizes, which are individually useful in different ways due to the different properties. So the purpose of a refinery is to separate and purify these different components. Most refinery products can be grouped into three classes. Okay, the light distillate, that is the naphtha and gasoline, the medium distillate, the kerosene and diesel, and the heavy distillates, fuel oil, lubricating oil, waxes, and tar. If you saw a barrel of crude oil and we go to the oil refinery processes, we can see this proportion more or less of the refined product that we can get. We can get 4% of liquefied petroleum gases, LPG, 40% gasoline, 12% distillate, 15% diesel, and fuel oil. How do we get from here to here? through different processes. The main processes are the separation and the conversion, treatment, and then blending of the product to get the final product specification. How do we get all the processes? With the assistance of heat, pressure, catalysts, and additive. During the next online sessions, we will see all the process involved in the Carvalha refinery. So we will see the separation, that is mainly the crude oil distillation, that we will see the atmospheric and the vacuum distillation. Then they will see the conversion, where do you have the isomerization, do you have the catalytic reformer, do you have the fluid catalytic cracking. So you have a lot of processes that we will see in the next session classes. So what you will use in Carvalha refinery mainly crudes from two places, from Basra and from Misri. And you will process it in the grassroots refinery that will process 140,000 barrels per stream day of crude. These capacities are based on the first unit capacity processing, that is the crude oil distillation column, that is capable to process this quantity of crude oil. So the crude oils, you have the Basra regular, you have the API degrees 34, the Mishrif with 28.12. Then we have the Basra new crude oil and the Mishrif new crude oil. In the next presentation, we will talk about the meaning of this degrees API, okay? So the crude oil is delivered to the refinery by crude oil receiving line from crude oil receiving station. So you will receive the crude oil in the refinery by crude oil pipelines. And the crude oil will be stored in external floating roof tanks in the refinery with 8 days of inventory, okay, of crude oil. Each refinery has a proper scheme depending on the products that you would like to get. And in the case of the Carvalha refinery, the production target is mainly transportation fuels for the Iraqi market. Also, some heavy fuel oil will be produced for the Al Kharid power station, and other products will be the bitumen and solid sulfur. The solid sulfur, it is because, as we saw in the second slide, the crude oil is composed mainly by hydrocarbons, but of course, crude oil also contains some sulfur, and this sulfur has to be removed prior to go to a conversion processes, and this is finally converted to solid sulfur. The Carvalha refinery configuration is comparable to a medium conversion scheme based on the vacuum gas oil treatment and fluid catalytic cracking technologies, with the objective to obtain a significant conversion of heavy materials into the sulfurized gasoline as secondary distillate. But as I told you, we will see later in different sessions all these process units, the main characteristics and the feedstock and the products you will get from each process unit. So with this slide, we have finished this first presentation, that is what is crude oil. So if you have any question, or Ahmed?
Yeah, so we've done the first part of the presentation today. So
Yes.
what's the crude oil? So guys, if you have questions, just let us No, so either you talk directly or you raise a hand. There is an option you can raise your hand using Zoom. So, شباب وشابات اللي عنده أحد سؤال. Okay, so one note we've got is the voice. I think next presentation, Pilar, if you just you raise your voice.
Okay, perfect.
Louder, yeah, because.
Okay, as you told me the other day, no, that
Yeah.
maybe.
So,
Yeah, okay.
so keep that in mind, yeah, when you start
Okay.
the next session, yeah. Thanks.
Okay.
Okay. Let's see, check. Yeah, there's a question from Mustafa. تفضل مصطفى. أستاذ مصطفى ممكن تحكي يعني سويت لك انميوت يعني تقدر تتكلم. أستاذ مصطفى تسمعني؟
أعتقد أستاذ أحمد في مشكلة نت أو شيء من الخبير.
بس دقيقة. علي اوكي هسه سويت لك اني ميوت فتقدر تتكلم استاذ علي.
استاذ السلام عليكم.
السلام ورحمة الله.
اتكلم ويا حضرتك دايركت لو وياها؟
بكيفك تريد تحكي وياها احسن يعني افضل دايركت.
ماشي. Hi, please. I'm talking about this lecture. Please, can you send it before one day for a paper and see this lecture, and we can discuss.
What happens? The problem with the paper, most the presentations we have for the pre-training, they are much higher in terms of the data.
Yeah, we need see and keep it in our mind. After that, we can discuss in this lecture, please.
Okay. We'll see. We will find a way for the next sessions. We will find a way to send you the presentation.
Another question.
Yeah.
Okay. Another question about the sound. It is very slow. Please, you can give more high sound.
Okay, no problem. No problem.
Okay. Thank you so much.
Any more questions, guys? Okay. So shall we take what time now? So shall we take 15 minutes of break? So we can start 5 past, yeah?
Okay, perfect.
Yeah. So and then we can start with the next presentation.
Okay.
Yeah, 5 past, yeah. Okay. Thank you so much.
Thank you.
Thanks.
Okay.
Pilar, you can start the second part, which is crude oil overview. Thank you so much. And just keep in mind, make sure that always remind yourself the voice, just make it a bit louder, because the connection over there is not that strong sometimes. So it's better just to raise your voice most of the time. Yeah. Thank you so much.
Okay. And please let me know if I have to raise my voice more. You can send me a message in this chat, or you can raise your hand, okay?
Sure. Thanks.
Okay. So welcome again. Now we are going to go through the second presentation, that is the crude oil overview. In this presentation, we will talk about the crude oil properties and classification, density, specific gravity and degrees API, sulfur content, power point and viscosity, basic sediment and water, ash content and carbon residue, total acid number, and total nitrogen and asphaltenes, okay? Okay, it is important, of course, if we are going to process crude oil, to understand the basic properties of the crude oil. That is the key raw material process in the refinery. Crude oils are not the same, but rather that vary in color, composition, and consistency. As we saw in the previous presentation, the Carvalho refinery crude slide comprises these four types of crude oil: two from Basra, one with 34 degrees API, and the Basrani crude oil with 32.5. And we have the crude oil from Midtrip with 28.12 and the new crude oil with 26.4. Oil is classified according to three main categories: the geographic location, the API gravity, and the sulfur content. So we will talk about many of these properties of the crude oil. These are some of the basic properties of the crude oil that will be treated in the Carvalho refinery. That I took it from the operating manual of the crude oil and vacuum distillation unit. So we will see here the identification of the crude oils, okay? That is the specific gravity, the API gravity, sulfur, 4 point, basis sediment and water, ash content, asphaltenes, the kinematic viscosity at 2 temperatures, the total nitrogen, the total acid number, and the carbon residue. So you will have here the values for the 4 cases of the crude oils to be processed in the refinery, okay? So here, okay, you have this specific gravity for the four crude oils. So the idea in this presentation is that we will go through all these properties to explain the concept of each one, okay? So we will start with the density and specific gravity. And here in this small square, you will have the specific gravity for the crude oils to be treated in the refinery. So the density. The density is defined as mass per unit volume of a fluid and is shown by rho. The SI unit for density is kilogram per cubic meters. The liquid density decreases as temperature increases, but the effect of pressure on liquid density at moderate pressure is usually negligible. So it's not like in the gases. Two liquid densities related properties of oils are often used: the specific gravity and the API gravity. A specific gravity. What is the specific gravity? It is an index used to measure the density of a liquid, but it's calculated as a ratio. A ratio of what? Of the density of the liquid to the density of the water, okay? Is this density of the liquid divided by the density of the water. A specific gravity, because it is a ratio of two equal dimension quantities, it is a dimensionless quantity, okay? You saw here, the specific gravity is 0.855 without any dimension, okay? Liquids with a density lower than water, which includes most of the crude oil grades and petroleum products, will have a specific gravity between 0 and 1. Okay, so it is important to remember these concepts, because this specific gravity, we will use it to calculate the API degrees. So remember, the specific gravity is a relation, is a ratio between the density of the crude oil or the density of any liquid divided by the density of the water at a reference temperature. So what is the API degrees? The American Petroleum Institute gravity, or API gravity, is a measure of how heavy or light a petroleum liquid is compared to water. If its API gravity is greater than 10, it is lighter and floats on water. If it's less than 10, it is heavier and sinks. API, American Petroleum Institute, is a trade association of firms engaged in all aspects of the U.S. petroleum industry, including producers, refiners, marketers, and transporters. API gravity is a little bit tricky because it's an inverse measure of the petroleum liquid specific gravity, and it is used to compare density of petroleum liquids, okay? Although API gravity, we will see the formula, is mathematically a dimensionless quantity, it is often refers to as being at degrees, okay? So the formula to calculate the API gravity from a specific gravity is the following, okay? This is a formula to calculate the API gravity. So it is 141.5 divided by the specific gravity minus 131.5. If we put here, for example, the specific gravity of the water, that is 1, because it's the density of divided by the density of the water divided by the density of the water, that is 1. So we will get 10. So the AP gravity of water would be 10. 141.5 minus 131.5. So as you can see, if you have here a lower number, you will have here a higher and this a higher number. That's why it's the inverse. You have a low specific gravity, you have a higher API gravity. So oil with low densities and hence low specific gravity have high API gravity. The price, of course, of a crude oil is usually based on its API gravity, okay? With the high API gravity, that it means that you have a light crude oil, it is a commanding higher price because it can produce more quantity of the light products in the refining processes, okay? And these light products have a higher price in the market. So that's why a light crude oil will be always more expensive than a heavy crude oil. The typical values, if we compare different substances, we have the water, as we saw. If we have a specific gravity of the water that is 1, we have an API gravity of 10 degrees. For gasoline, that is usually has a specific gravity of 0.74, you have an API gravity of 60. For a light crude, that the specific gravity is more or less 0.84, you will have 36 degrees. But for a heavy crude, that the specific gravity is 0.95, you will have an API gravity of 18. So you will see here that a light crude has a higher API gravity than a heavy crude, okay? So for lower specific gravity, higher API gravities. So the crude oil, they are classified according to the degrees API. So let's see how they are classified. So they are light crude oil if the API gravity is higher than 31.1. They are medium oil if the API gravity is between 22.3 and 31.1. There are heavy crude oil if the API gravity is below 22.3, and extra heavy has a gravity below 10 degrees, okay? Here we have the APA for the crudes that will be treated in the refinery. We have the Basraf crude with API degrees higher than 31.1, so it is classified as light crude oil. And we have the midstream crude oil that is the API gravity is between 22 and 31.1, so it's classified as a medium crude oil. Okay. You will see here the classification in an arrow: light, medium, heavy, and extra heavy according to these values. Okay. So it is always good to remember that crude oil, light crude oil, the API gravity is higher than 31.1. Okay. Now we will see another very important element in the crude oil, that is the sulfur. Okay. The sulfur content is quite important in the classification of the crude oils. Why? Because it's not good in the crude oil. Okay, so we have to extract this sulfur because it's when burned, it will generate the sulfur oxide. So that's why it's an undesirable contaminant in the crude oil and in the petroleum products. When the sulfur dioxide is created in the combustion of the sulfur, and this sulfur dioxide combines with water and air, it forms the sulfuric acid, which is the main component of the acid rain. Okay, and as you know, the acid rain can cause deforestation, can acidify the waterways to the detriment of the aquatic life, and corrodes building material and plants. Okay. So if we see here, this industry here, refinery or industry that creates through the combustion of material containing sulfur compounds, create, or of course also nitrogen, but nitrogen is in a lower degree in the crude oil. The sulfur dioxide and nitrogen dioxide combined with the water will create this sulfur acid and nitric acid, and then will create the acid rain. Of course, also acid snow, acid particle, and gases, and will cause one of the main causes, the deforestation. Main consequence of the acid rain is the deforestation. Consequently, most finished petroleum products have a limit on how much sulfur they can contain, making sulfur removal an important part of the overall refinery process. Okay, so it is very important that we will see that in the refinery, we will, when we study all the process unit, you will see a lot of hydrotreating to remove these sulfur compounds in the crude oil and also in the side stream from the, mainly in the side streams from the crude oil distillation to meet this specification on the final product. So just remember that the acid rain results where sulfur dioxides and nitric oxides are emitted into the atmosphere, and of course they are transported by wind and air currents, and this reacts on water and form the sulfuric and the nitric acid. And important also, very important, because we use in the process of the refinery, in the catalytic process, we also have a very important catalyst and very expensive catalyst, and the sulfur can also harm some of the catalysts. So that's why also, not only to this reason, but also due to this reason, the sulfur has to be removed from the intermediate stream because before they can be fed into the conversion unit where the catalysts are present. How do we classify the crudes according to the sulfur content? As we saw, this sulfur in the crude oil is the second most important property next to the API. So there are two terms to classify the crude oil according to the sulfur content, sweet and sour. And these are reference to the sulfur content of crude oil. It seems that early prospectors would taste oil to determine its quality. And the low sulfur actually tasting sweet. So that's why they classify as sweet and sour. If we use the content of the sulfur to classify the crude, we say that this crude is sweet. If the sulfur content is less than 0.5% weight. And it's sour if the sulfur content is greater than 0.5% weight. Okay, so we have here the sulfur content of the crudes of the Buff Rap and the Mixed Reef. Okay, we can see that for the 4 cases, the sulfur content is greater than 0.5%. So we can say that the crude oils that will be processed in the refinery, there are sour crudes. Okay, so we have here sweet and sour crudes. So it is remember that sulfur content is one important issue in the crude oil. Another important property in the petroleum, in the crude oil, is the pour point. The pour point of a crude oil or a petroleum fraction is the lowest temperature at which the oil will pour or flow when it is cooled without stirring under the standard cooling condition. When the temperature is less than the pour point of a petroleum product, it cannot be stored or transferred through a pipeline. So it is very good to know which is this temperature. The pour point of crude oil relates to the paraffin content. We saw in the next presentation the meaning of paraffin, but I know there are the alkanes in the hydrocarbons. So the higher the paraffin content, the higher the pour point. Okay. So we will see here the temperatures, the pour point of the crude oils that we will process in the refinery, in the Carvala refinery. So you will see that minus 24, minus 36. So it means that if you go below these temperatures, the crude oil will not flow without any additional help. So of course, this has many implications, especially within engines, and is also give you a good indication of the viscosity for the engines, and they will prevent the mainly in the gasoline blending. And the to refresh, this pour point represents the lowest temperature at which oil is capable of flowing under gravity. Okay, so it is one of the important low temperature characteristic of the high boiling fractions in the crude oil. Let's talk now about viscosity. Okay, the viscosity of a liquid is a measure of its resistance to flow. Viscosity symbol is mu. Water, gasoline, and other liquids that flow freely have a low viscosity. Honey, if you compare with honey, syrup, motor oil, and other liquids that they don't flow freely, they have a high viscosity. The most commonly used unit for this dynamic or absolute viscosity is the centipoise. The power requirement to transport a fluid depends strongly on this viscosity. So how is the viscosity with temperature? The viscosity of the liquid decreases with increasing temperature. But in the gases, the viscosity of the gases increases with increasing temperature, but not in the liquid. So we can see here a test, an experiment. This is for motor oils with lower viscosity and higher viscosity. If you put a metallic ball, you see how far the ball gets into the tube due to the viscosity, okay? So among the petroleum product, viscosity constitutes a critically important characteristic, mainly in lubricating engine oils, okay? So this is the dynamic viscosity, but also we see the viscosity expressed as the kinematic viscosity, okay? The kinematic viscosity is usually in terms, is the ratio between the absolute or dynamic viscosity that we saw in the previous slide divided by the density of the liquid. And if often the unit used for the kinematic viscosity is the centistoke. Usually, the values of the kinematic viscosity are reported at 2 reference temperatures. This measure of viscosity and kinematic viscosity are used frequently in engineering, fluid dynamics, and for practical applications. Okay, I will raise my voice. Okay. This measure of viscosity and kinematic viscosity are used frequently in engineering fluid dynamics and is very practical applications through pipelines. When you calculate the pipeline, this is a common data that you will have to use is the viscosity that will tell you also the pressure drop across the pipelines. Here you will see the kinematic viscosity for the crudes in the refinery. As you can see, they are referred to 2 temperatures, at 20 degrees and at 40 degrees. Of course, in centistoke, as we saw previously, that is a common unit used. What can you see here about this kinematic viscosity at 2 temperatures? Let's see, for example, the mixed-reef crude oil. At 20 degrees centigrade, you have a viscosity of 29.3 centistokes. If you have at 40 degrees, the same crude oil, we have a lower viscosity, 14.25, okay? So this is a property, it is very important for the fluid dynamics of in the refinery, okay? For the pipelines and also for pumps. Another important property of the crude oil is the basic sediment and water, BS and W. The amount of water, salts, and sediment in the crude oil as received at petroleum refinery varies widely with the source of the crude oil, of course. The prior processing of the crude oil at the source sites and with the mode of transporting the crude oil from its source. The bulk of the water and sediment is usually separated at the field okay? Because they don't want to transport water to the refinery to minimize the quantity that needs to be transported further. The residual content of this unwanted impurity is measured at BSW, that's basic sediment and water. Crude oil at the refinery requires desalting to minimize fouling and corrosion caused by salt deposition on heat transfer surfaces and acid formed by the composition of the chloride salts, and to remove suspended solids from the crude oil itself. We will see in next online session that is next week, when we talk about the crude oil distillation, that we will talk about this first section of the unit, that is the salting of the crude oil, okay? That is accomplished before the crude oil distillation, and this first session we will remove all these, and especially the chloride salts that are present in the crude oil. So it is quite important also in the refinery, this first process. We see here the content, the BSW volume percent in the crudes that we will treat in the refinery. Another important property of the crude oil is the ash content. The ash content represents the incombustible component remaining after a sample of the furnace oil is completely burned, okay? The ash content in the crude oil is an indication of its metallic constituents. The ash left after completely burning an oil sample consists of stable metallic salt, metal oxides, and silicon oxides. So it will give you an indication of the metal contents in the crude oil. Some of the ash forming constituents occur naturally in the crude oil. Others are present as a result of refining or contamination during storage or distribution, okay? So we can have in the crude oil, or also they can get the metals in the storage tanks. The presence of ash in the crude oil, that is an indirect measurement of the metal content in the crude oil, is unfavorable because these metallic compounds cause corrosion and poison the catalyst that we will use in the refinery processes. The higher also the ash content is, the higher the tendency of the crude oil to form a sludge or sediment. Okay, so this, well, all important, but this ash content is also quite important. So now we will see the carbon residue. The carbon residue is, for a fossil use, can be defined as the tendency to form carbon deposits. In this case, it's at high temperature in an inert atmosphere, okay? Carbon residue for a fuel is measured in weight percentage, or part per millions by weight, milligrams per kilograms. Carbon residue relates to asphalt content of oil and indicates the tendency of falling in heated tube and catalyst also deactivation. The ash-forming constituents will be also part of this total carbon residue. So we will see here, this is the carbon residue in the crude oils in the refinery, in the Carvala refinery, according to the data that is included in the operating manuals. Another important properties of the crude oils is the TAN, that is the total acid number. Okay, remember TAN. We abbreviate TAN. The acidity in crude oil is usually described by the total acid number, okay, which is defined as the amount of potassium hydroxide required to neutralize 1 gram of oil sample, okay? We have here the number for the Carvajal crude oils. What is important to know the tan, because this tan indicates whether any special metallurgy needs to be considered in the refinery as a result of the acid corrosivity in the crude oil. If we have a very high acid, we will need a special metallurgy in the refinery. There are said that if the crude oils have a tan greater than 0.7 milligram of potassium hydroxide per gram are highly corrosive to refinery equipment. In our case, well, the tan is lower than this value, okay, than 0.7. Another important parameter to evaluate in the crude oil is the total nitrogen. The total nitrogen normally the crude oil contains low level of nitrogen compounds compared to the sulfur compounds, okay? We are talking about here a milligram per kilogram, so we are talking about in ppm, okay? A high nitrogen content is undesirable because nitrogen compounds can cause severe poisoning of the catalyst used in the refinery. So you have seen that the catalysts are also referred in all these processes because we have a lot of catalysts in the refinery and they are quite expensive, so we have to take care of them. So the nitrogen compounds can cause also corrosion problem, so the hydrogen blistering and gum formation in the refinery process. This hydrogen blistering, this refers to the formation of surface planar cavities that are called the hydrogen blisters in a metal. These are resulting from the excessive internal high hydrogen pressure. So this is caused by nitrogen compounds. The crudes containing nitrogen greater than 2,500 milligrams per kilogram require a special removal process. In our case, the content of the nitrogen in the crude oils that will be treated in the Carvajal will be processed in the Carvajal, the nitrogen content is lower than 2,500. Now we will talk about the asphaltenes. The asphaltenes are molecular substances that are found in the crude oil along with resins, aromatic, hydrocarbon, and saturates. The word asphaltene was coined by Buchenwald in 1837 when he noticed that the distillation residue of some bitumen had asphalt-like properties. The asphaltenes negatively impact the economic value of the crude oil. An oil's viscosity depends directly and especially on asphalt content. I can tell you the asphaltenes is a very complicated molecule, a structure molecule. They consist of hydrogen, carbon, of course, nitrogen, oxygen, and sulfur. And these are polynuclear aromatic structure, and they consist of 20 or more aromatic rings, okay, along with paraffin of nasthenic chains. So the asphaltene, as asphaltene content increases, also the viscosity and the density increases. So the asphaltenes are known to be one of the largest causes of fouling in the heat exchangers of the crude oil distillation preheat train. We will see also in the next session this preheat train and the importance of the preheat train in the refinery to the lower energy consumption, for the lower energy consumption. So this is the last slide for this presentation. If you have any question or otherwise, we will move to the last presentation that is called hydrocarbons. So Ahmed.
Yeah, so just let's check if any of the ladies and the gentlemen, they have a question. So just let's see. شباب اكو احد عنده سؤال قبل ما نروح للاخر بارت مال البرزنتيشن اللي هي يعني موضوعها على الهيدروكربونز. اوكي let me check. Final check.
أحمد السلام عليكم.
السلام ورحمة الله. هلا ودكتور. هلا وعيني.
أستاذ أحمد الأستاذ ظافر ما موجود، أنا مكانه إذا أي تبليغ أو شيء. أنا موجود في المحاضرة يعني.
أوكي تسلم دكتور.
أوكي يعني.
أوكي يعني هو باقي عندنا بس بارت الأخير اللي هو على الهيدروكربونز يعني. Okay. I can see most of people, they want the presentation one day before the session, so we'll find a way to send the material.
To send it before, yes.
Yeah.
It's a good idea,
They
yes.
can have time before the presentation to review, so they will have, I think, a bit more questions.
Mm-hmm.
Okay, yeah, no problem. I think you can move to the next, how many slides the hydrocarbon?
I think that 20, no? More or less.
Yeah. Okay. Yeah. We can finish it off. Yeah.
We have to finish. Do we have an estimate hour when we have to finish or not?
If we say finish it with 1 hour, I think that would be good. Yeah.
Oh yeah.
Okay. You can start. Yeah. Thanks.
Okay. So now we will start our last presentation for today, that is hydrocarbons. Okay. Of course, I'm sure that many of the concepts will be very familiar to you, but we'll make a refreshment of these concepts. So in this presentation, we will see the hydrocarbon definition. We will talk a little bit about the carbon atom, the hydrocarbons classification, the hydrocarbon and crude oil, and some example of known hydrocarbon compounds. Definition. Okay, the hydrocarbons are the simplest of all organic compounds, containing only carbon and hydrogen. Okay, the carbon atoms join together to form the framework of the compound, and the hydrogen atoms attach to them in many different configurations. So the hydrocarbon are the principal constituents of crude oil and natural gas. They serve as fuels and lubricants, as well as raw material for the production of plastics, fibers, rubbers, solvents, explosives, and industrial chemicals. So the size of the hydrocarbon molecules affects the physical state. Hydrocarbons can take many different forms. The smallest hydrocarbon is methane, CH4, which is a gas under ambient conditions. So this is the methane that you have here, 1 carbon and 4 hydrogen, 1, 2, 3, and 4, okay? Longer chains with 5 or more carbons are liquid under ambient conditions. Here in this picture, we will have the pentane. Pent, that is meaning 5. You have the 1, 2, 3, 4, 5 carbons and 12 hydrogen. Very long chains are solids like wax or tar under ambient conditions. By chemical cross-linking hydrocarbon chains, you can get everything from synthetic rubber to nylon to the plastic in the Tupperware. So yes, you can see the hydrocarbon chains are very versatile, okay? That it is quite important to know the definition and the hydrocarbon, because from hydrocarbon there is a huge industry behind the hydrocarbons. So let's talk about the carbon, that is the king of the organic chemistry. So the carbon atom is unique among elements in its tendency to form extensive networks of covalent bonds, not only with other elements, but also with itself. So as you saw the other day when you talk about the periodic table, carbon is neither an electropositive or an electronegative element, so therefore it's more likely to share electrons than to gain or lose. That is the tendency to form the covalent bonds, okay? The carbon-hydrogen bond, that is the CH bond, is a covalent bond, meaning that carbon shares its outer valence electrons with up to 4 hydrogen. This completes both of their outer shells, making them stable. Okay, if we see here, this is the carbon atom. We will see here that we have the 6 protons and the 6 neutrons. So the atomic weight of the carbon is 12. And it also has 6 electrons, 2 and 4. So as you know, the octet rule is the chemical rule that the tendency that to form the 8 electrons in the outer shell. So we have 4 here in the outer, but you have 4 empty spaces here. So the carbon will tend to share with another compound or element these 4 electrons to give the stability to the carbon atom. This octet rule is applicable except for the hydrogen, that is can hold a maximum of 2 electrons in its valence level. Okay. Why they want to give the octet rule is because it have the same configuration of a noble gas. Okay, so it is a tendency to form to cover all the outer shell. That's why the carbon atoms tends to form the covalent bonds, to share electrons with other component and to fill the outer shell. How the hydrocarbons are classified? The hydrocarbons are classified in alkanes, alkenes, alkynes, and aromatics. Okay, so we will see each of these groups here. The alkanes are the saturated hydrocarbons. So the saturated hydrocarbons are the simplest of the hydrocarbon species. As I told you before, these alkanes are also known as paraffins. Okay. So these they are composed entirely of single bonds and are saturated with hydrogen. The formula for acyclic saturated hydrocarbons is CnH2n plus 2. These saturated hydrocarbons are the basis of petroleum fuels and are found as either linear or branch species. Hydrocarbons with the same molecular formula but different structural formula are called structural isomers. So you can see here the butane, 4 carbon atoms. If you 4 times 2 plus 2, so this is C4H10. This is called the linear paraffin, okay? And we have here the branched, that is the, for example, the isobutane, okay? That is the 2-methylpropane, okay? Also here we have another example of the alkane. We have the N or normal pentane, that is the linear alkane, where you have the 5 carbon. You see you have the 4 bonds in each carbon, 4, okay? And then you have the C5H12, that is the pentane. You can have also other C5H12, like isopentane or the neopentane, okay? We will see later an example how do you, that is the isomers for the pentane. So let's remember that these saturated hydrocarbon are the basis, okay, of the petroleum fuels and the crude oil, okay? You can find it as linear or branched bases. And remember that alkanes are also known as paraffins. So we have different types of alkanes. We have the linear or straight change that have the carbons bonded together in a chain-like structure, similar to a snake that we saw here, okay? We have here the branched alkanes are derived from linear alkanes, but instead of having just a straight change in their chemical structure, it is branched with one or more alkyl groups, okay? We will see later what is the alkyl group. That is a group of carbon and hydrogen attached to an alkyl molecule. We will see the naming of these alkyl groups. The cyclic alkanes or cycloalkanes consist of hydrogen and carbon atoms bonded together with single bonds where the carbon atoms bond together to form a ring. We will see also later these cycloalkanes and remember that's not the same as the aromatics, okay? So we will see the difference. So we have here some examples of the straight change or linear alkanes. We have here branched alkanes that we see here, all these alkyl groups attached to the linear alkane. And we see here the cyclic alkanes, okay? Cyclobutane, pentane, hexane, ethane. These cyclic alkanes, we'll see later, are also called naphthalene, okay? In the crude oils, the most are the cycloalkanes that we can find more are these 5 and 6 cycloalkanes, okay? These compounds, they are not aromatic, but they are very used also in the processes of refinery because they can be transformed to aromatic through catalytic conversion, okay? How do we name a linear or straight change alkanes? This is the common suffix for the alkanes, the "ane" for the alkanes. And we will see here the names, okay? The simplest alkane is the methane with only one carbon. We'll see here the molecular formula and the structural formula. And in this column, we will see the number of possible isomers, okay? So we'll see the methane, we don't have isomers, we don't have another way to put the 1 carbon and 4 hydrogen, neither with the ethane, that is the C2H6, we have the propane with its 3 carbons and 8 hydrogens. We have butane with 4 carbons and 10 hydrogens. We have the pentane with 5 and 12 hydrogen. As you can see, from butane, you can have another way to put the butane, so having these 4 carbons and 10 hydrogen in another way. So you have 2 possible isomers. For the pentane, you will have 3 possible isomers. For the hexane, that you have 6 carbon and 14 hydrogen, you have 5 possible ways. For the heptane, that is C7, H16, you have 9 possible isomers, and so on. And so for the decane, that you will have 10 carbons and 22 hydrogen, you will have 75 possible isomers, 75 possible ways to put 10 carbons and 22 hydrogens. So the alkyl groups that we saw before with the branched alkanes are named in this way, okay? From the methane, you replace the "-ane" suffix by an "-il", okay? So methane will be methyl, okay? Of course, with 1 hydrogen less than the methane that will be attached to another atom of carbon or another compound. From the ethane will be ethyl, that is C2H5. From propane will be propyl, that is CH3, CH2, CH2. And from the butane will be butyl, CH3, CH2, CH2, CH2. You will see also this R, that is like a generic unspecified alkyl group. Okay, you will see with the when you see this R attached, for example, to a sulfur, it means that it's a sulfur attached with any kind of alkyl group. Okay, so this is a way to name the branch alkanes using these alkyl groups naming from the alkanes, the corresponding alkane. Okay. So there is a rule. There are rules to name the branch alkanes. So we will see these rules in the next slide. So the UPAC, that is the International Association for this chemistry, for the applied chemistry, they say they have these rules to name the branch alkane. First, we have to find and name the longest continuous carbon chain. Then identify and name the groups attached to this change. Then to number the change consecutively, starting at the end nearest a substituent group. Then designate the location of each of these substituent groups by an appropriate number of name. Assemble the name listing groups in alphabetic order using full name. The prefixes D, 3, tetra, etc. used to designate several groups of the same kind are not considered when alphabetizing. These are the rules by the UPAC, but as organic chemistry grew and developed, many compounds were given trivial names, which are not commonly used and recognized. We will see some examples in the next slides that they don't follow exactly the UPAC rules. So we will see here an example for the isomers. So let's take as an example the pentane, okay, that is the C5H12. So we put the 5 carbon atoms in a row, then we fill with hydrogen to have each carbon 4 bonds, So we have here the pentane, okay, that is the C5H12, okay. Then we can also write the same, the C5H12, we can write, put it here in another way, in another arrangement, okay. As you can see here, in this arrangement, you will have also the 5 carbons and the 12 hydrogens. Also in this arrangement, okay? You will have the 5 carbons and the 12 hydrogens in a different arrangement. How do we name it in this branched alkane? First, we'll have to find the longest change. In this case, it is this 4 carbon change. So we know that we will name as butane, okay, butane. And then we will find the alkyls. In this case, we have a methyl alkyl attached to this butane. Where do we have it? In the second carbon. So we will call the 2-methyl butane, okay? Of course, you can see also that, okay, you have the longest change. You could also draw it like here, this, that you will have 4, but it's the same because we have the butane, and this would be the alkyl attached to the second carbon. So we'll have also the 2-methyl butane. In this case, we'll have the longest change is a 3 carbon change. So we'll have a propane, okay? In this way or in this way, only in this way will be the same, okay? We have a 3 carbon change. So we will put that is a propane. So what kind of alkyls do we have? We have a methyl, CH3, remember methyl from the methane, from the alkane. We have the methyl group, alkyl groups. We have 2 methyl groups. So, and where do we have? In the second carbon. So we name it 2,2-D because we have 2-dimethylpropane, okay? So as you can see, this pentane, the 2-methylbutane and the 2,2-dimethylpropane, they are the same C5H12. So 3 different compounds have the same molecular formula. That is important, very important to know that even if they have the same molecular formula, they have different properties, okay? That we will see when we saw in the different processes of the refinery, the importance of this difference with the same formula of the hydrocarbons. So if we compare the boiling point of these 3 components, we will see that of these different compounds, we will see that the pentane has a boiling point of 36 degrees C. The 2-methylbutane, we have a boiling point of 28 degrees centigrade, but the 2,2-dimethylpropane has a boiling point of 9. So if you can see, there is a big difference between the 36 and the 9 degrees in the 2,2-dimethylpropane. As you can see, if you have more branch hydrocarbon, the boiling point will be lower. It is easier to become to vaporize. So the different compounds having the same molecular formula are called isomers, remember? And the greater the number of carbon atoms, the greater the number of possible isomers. So one of the also, apart from the boiling point, it's very important in the refinery to know that the octane number, that is quite important in the gasolines, also is very related to the branch of the alkanes. We see that the octane number reference is referred to a branch alkane, okay? That is the 3-methylpentane. That is a high, the octane number is 100. That is like the reference for the octane numbers of the gasoline. So you will see that it's quite important when we will see also the blending chapter on the online sessions. So we have seen here the naming of the branch alkanes. We will see here, we have seen also the isomers definitions, the importance of the isomers, and to see that even if they have the same molecular formula, they can have quite different properties, okay? So we have seen the alkanes. Now we will see a little bit about the alkenes. Okay, we have already seen the alkanes. We will see the alkenes. The alkanes are unsaturated hydrocarbons, having one or more double or triple bonds between carbon atoms. Those with double bonds are called alkenes. The name of a specific alkene always ends in "-ine" and has a prefix indicating the number of carbon atoms. The UPAC gives the alkanes a name of "-ane", so we will replace for these alkenes with the "-ine". Okay, as we saw before, there are some very known alkenes that are not known by the UPAC numbers names, but are also known by the common names. These are two examples. We have here the ethene, there are two carbons with a double bond and the 4 hydrogen. And according to the UPAC, you should name it ethene, but I'm sure that you have heard a lot more ethylene than ethene, okay? So it's like the common name for this alkene. Also, another good example is the propene. There is the C3H6. You have here the 3 carbons, here you have the double bond and the 6 hydrogen. According to the UPAC, would be propene, but is usually named propylene, okay? The formula for these alkenes with one double bond, we have the formula CnH2n. That's why this is C2H4 C3H6, okay? So it is these compounds with double bonded are more chemically reactive, okay, than the alkanes. So that's why they are not found in natural products, okay? They are not found even either in the crude oil, okay? But they are, we will see it when we will talk about some of the processes within the refinery, okay? The other type of hydrocarbon, according to the classification, we can find the alkynes, okay? We have seen the alkanes, alkenes, so we will find the alkynes. The unsaturated hydrocarbon containing triple bonds, in this case, okay, are called alkyne. Those with one triple bond have the formula of CnH2n-2. The simplest alkyne is the acetylene, that according to UPAC is the ethene with the formula C2H2. How do we name these alkynes? In change with form or hydrocarbon, it's necessary to say where the triple bond is located. Example, let's see here. Okay, well, we have here the simplest, that is the ethene or acetylene. Do you have the triple bond here between these two carbons. Here, for example, we have the octane that is 8 carbons. In this case, we have the triple bonds here. So we have to name, okay, that is an octane, but we have to say where is the triple bond, okay? So in this case, it's in the 3rd carbon. So we will put it here where we have the triple bond, or in the middle, okay? So they are also, as the alkenes, very active chemically and are not found free in nature, okay? So we will not find any of these in the crude oil. Let's move to the following slide that we will talk about aromatics. Aromatics are also known as arenes, are a hydrocarbon that have at least one aromatic ring. They are called aromatic initially because of its fragrance. I'm sure if you have been, in the chemistry lab, that this benzene is the smell is like an almond, like almonds. Yes. The benzene that is C6H6 is the best known aromatic compound, and is like the parent to which numerous other aromatic compounds are related. The 6 carbons of benzene, here we have the benzene, are joined in a ring, okay, having the planar geometry of a regular hexagon in which all the CC bond distances are equal. As we saw before, you have not to get confused between aromatics and the cycloalkanes. Okay, here you can see the double bonds. In the cycloalkanes, there are not the double bonds. Okay, so this is the benzene. The largest group of aromatic compounds are those with which one or more of the hydrogens of benzene are replaced by some other atom or group, like a methylbenzene that is best known as a toluene, or dimethylbenzene that is known as xylene. Okay, so let's stop here. The benzene we have here, the C6H6. So if we replace one hydrogen by the methyl group, we have the toluene. Okay. If we replace 2 by 2 methyl group, we have the xylene. But of course, these methyl groups can be in this position, but I can also have be here or here. When they are close, adjacent to each other, they are called orthoxylene. When you have this configuration, you have the metaxylene, and when you have this configuration, you have the paraxylene. So the benzene is a natural constituent of crude oil and is one of the elementary petrochemicals. Okay, the benzene is a colorless and highly flammable liquid, and as we told before, with a sweet smell. It is used primarily as a precursor to the manufacture of chemicals with more complex structures, such as ethylbenzene and cumene. Okay, have the here the methyl, but also you can have here the ethylbenzene. Benzene has a high octane number. Okay, so aromatic derivatives are found in the gasoline pool, but the benzene itself has been limited because it's harmful to the health. It's known to be human carcinogen. It is important to the importance of the aromatics also in the plastics industry, in the polymers. This paraxylene, if you transform and you use with another chemicals, you can produce a well-known plastic that is the PET, the PET, that is what you find in the plastic bottles. So this is the aromatic industry is a huge, very well developed nowadays. So most of in some refinery, you have very close petrochemical industry where you can further manufacture petrochemical based on these aromatics. So this we have seen the main hydrocarbons. What we can find in the crude oil are mainly alkanes and aromatics, okay? Due to the chemical reactivity of the alkenes and alkynes are not found in the crude oil. But in this we'll find in some of the processes in the refinery. So the hydrocarbons in the crude oil, as we saw before, there are very wide and complex mixtures, okay, of hydrocarbons. Given the impossibility and uselessness of identifying the enormous amount of different hydrocarbons that are in the crude oil, these are usually grouped into the following families, okay? So we'll see the paraffins that we saw at the beginning of the presentation. The paraffin are the straight chain or branch alkanes. Quite important because it's the most important constituent of the crude oil. We have also the naphthenes or cycloparaffins in the crude oils, okay? That we saw that are alkyne cycle, that we saw that the main, there is the cyclopentane, the cyclohexane, okay? They are quite important also a constituent of the crude oil. And we saw the aromatics, okay? The aromatic rings. So these are the three most important families that we can find in the crude oil. The alkenes and alkynes are not found in crude oil and are mainly produced in the cracking processes in the refinery, okay? So also you can see sometimes classify the crude oil as a paraffinic crude oil, okay? Because of its constituent of the mainly of paraffins, okay? So the last slide in this presentation, well, only quite a few examples of 9 hydrocarbons. These are organic compounds, but no hydrocarbon, but some of the hydrocarbons have been replaced by other atoms as oxygen, nitrogen, phosphorus, or halogens. For example, sugar, okay? It's a compound of carbon, hydrogen, and oxygen. We also have the proteins that has, beside the carbon, hydrogen, they also have oxygen and nitrogen. And we have here the tetrachloromethane. So this is a review of the hydrogen, a very quick review, but we have covered the main concept of the hydrocarbons classification. So if you have any question, you can put it in the chat, or you can Ahmed will be revert to me.
Thank you so much, Pilar, for your effort for all the sessions today. And I would like to thank all the audience today. So guys, if you have any questions, please let me know. شباب إذا أحد عنده سؤال قبل ما ننهي المحاضرة.
أستاذ أحمد، السلام عليكم عزيزي.
السلام ورحمة الله. الأستاذ علاء.
نقدر نحصل هاي المحاضرة مسجلة يعني؟
اي تمام. انا ذيك المره اللي فاتت دزيتها الاستاذ حيدر واتصور يعني وصلها لكم يعني انا سجلتها مال اليوم كامله الثري بارتس يعني كلهن مسجله وادز لكم لينك لها.
شكرا جزيلا، ممنون من عندك، شكرا جهودك.
اوكي الله يخليك يا استاذ. Okay, I don't see any more questions or requests. Okay, so I gonna stop.
استاذ احمد شويه بس انا اشكرك طبعا واشكر المحاضره تارا طبعا على هذه المحاضره القيمه، خاصه كلاسيفيكيشن مال الكرود اويل طبعا كان كلش مهم طبعا. طبعا هاي المواضيع الاخوه الموجودين البارتيسبانت